sampling another dust devil during field campaign Morocco 2012. Credit Jan RaackDennis Reiss Swirling columns of sand and dust, known as dust devils, are a feature of desert areas on Mars and on Earth. Now, a study of terrestrial dust devils has shown that around two-thirds of the fine particles lifted by these vortices can remain suspended in the atmosphere and be transported around the globe. The findings have implications for the climate and weather of both planets and, potentially, human health here on Earth. Results will be presented by Dr. Jan Raak of the Open University at the European Planetary Science Congress EPSC 2017 in Riga, Latvia on Monday, 18 September 2017. The study by Raak and an international team of collaborators gives important insights into the contribution of dust devils to mineral aerosols in planetary atmospheres. About half of the dust lifted into the Martian atmosphere each year is thought to come from dust devils. However, to date, the structure of these vortices has not been well understood. As terrestrial dust devils act very similarly to those on Mars, Raak and colleagues have carried out multiple field campaigns over the past 5 years to study dust devils in 3 different deserts on Earth: in China, Morocco and the USA. The researchers took samples of grains lifted by dust devils at different heights, studied tracks left by dust devils on the surface, and measured physical and meteorological properties of dust devils. Raak explains the method for sampling is simple, although not actually that pleasant to carry out as it involves getting sandblasted. Essentially, we cover a 5-meter aluminium pipe with double-sided sticky tape and run into an active dust devil. We hold a boom upright in the path of a dust devil and wait until the dust devil passes over the boom. Numerous grains are collected on the sticky tape, which are preserved on-site by pressing sections of the tape from different heights onto glass slides. Very distinct dust devil in some distance during field campaign Morocco 2016. Credit Jan RaackDennis Reiss. Back in the lab, the glass slides are analyzed under an optical microscope, and all grains measured and counted to gain detailed relative grain size distributions of the sampled dust devils. The results presented at EPSC 2017 focus on samples taken during field campaigns in the south and southwest of Morocco, funded by Europlanet and supported by the IBN Battuta Center in Marrakesh. We found that the dust devils we measured have a very similar structure, despite different strengths and dimensions. The size distribution of particles within the dust devil seems to correspond to the distribution of grain sizes in the surface they passed over. We have been able to confirm the presence of a sand skirt, the bottom part of the dust devil, with high concentration of larger sand grains, and most particles were only lifted within the first meter. However, the decrease in grain diameter with height is nearly exponential, says Raak. In the terrestrial dust devils, the team found that around 6,070% of all the fine dust particles with diameters up to 0.03 of a millimeter appear to stay in suspension. These small mineral aerosols can be transported over long distances on Earth and have an influence on the climate and weather. They can also reach populated areas, affecting air quality and human health. On arid Mars, where most of the surface is desert-like and the dust content is much higher, the impact is even larger. Further analysis of the datasets will include meteorological measurements of the dust devils that will be used to interpret data obtained by landers and rovers on Mars, including the Curiosity rover and the upcoming ExoMars and InSight lander missions. Animation of Dr. Jan Raak running to a dust devil and successful sampling of it during field campaign Morocco 2016. Samples will be analyzed soon. Credit Jan RaackDennis Reiss. Animation of sampling a very small and weak dust devil during field campaign Morocco 2016. Samples will be analyzed soon. Credit Jan RaackDennis Reiss. Explore further dust devils with by Spirit. More information Jan Raak et al. In situ sampling of relative dust devil particle loads and their vertical grain size distributions, Astrobiology 2017. doi 10.1089 ast.2016.1544 Journal reference Astrobiology provided by Europlanet Media Center.